Hello everyone. Today, let's discuss about the general topic, which is model-based learning in the field of reinforcement learning. As we already know the ideology about the reinforcement learning, let's understand the key concepts about the model-based learning, its basic introduction, and how its applications are done in real day-to-day lifetime. So let's move into the concepts. This model-based learning in machine learning is a simple technique or an approach that tries to generate a custom model or a custom solution for every or new challenge. Now let's see about the different three key ideas which is used in the concept of model-based learning. The purpose of this is to offer a single development framework that facilitates the building of a diverse variety of custom models. Through a single development framework, we can make use and bring about a lot of variety of custom models. So it proposes three ideas, namely factor graphs, Bayesian perspective, and probabilistic programming. And we can say that this learning is just a collection of assumptions which can be stated in a graphical representation. Now we need to understand certain terms in reinforcement learning. So the first term is agent. It can generally be a robot which is controlled or controllable. The second term is that it is environment. Environment, we can say that it is defined as the outside world programmatically. As we know, reinforcement learning is the deep learning which deals with the interaction with an environment in order to get a feedback. So it says that it proves the performance of the agent once implemented in a real world application. And the third important one is rewards. Rewards is the score of how the algorithm performs with respect to the environment. So it gives us if it is 1 means it is right, and if it is 0 means it is wrong. And the fourth thing is policy. So the policy is generally defined as the algorithm used by the agent to decide its actions. So this is the part that can be either model based or model free, but here we are discussing about the model based thing. So now let's see the first type, which is factor graphs. So these are the graphical representation which represents the factorization of a function of several variables. So if we see here, there are two types of nodes, namely variables and factors. So the variables here are evident variables or query variables, and the factors, these define the relationship between those variables. So here we can see the diagram where the circle represents the variable node and the square represents the factor node. And as I said, the ones which are inside the circle are known as the variables. So these can be written as g of x1, x2, x3, which is the function which is defined and which is equals to, and the next thing is we can see the factor nodes. So the factor nodes can be written, and the corresponding neighboring factors or variables can also be included and written. So this is all about factor graphs. Next one we are going to see about or discuss about is the Bayesian methods. So this is used for solving the complex data just by defining joint distributions of process and parameters. So there are two important concepts we need to see here, is that Bayesian inference and statistical inference. So the Bayesian inference is all about, it describes about the Bayesian probability, and basically it depends on the Bayes theorem. But here if you see, it is a technique used to accommodate new information to the existing data, and the statistical inference is all about updating the Bayes theorem. The above is the Bayes theorem, and this is updating the Bayes theorem. So here if you see the practical example and how it is defined, the basic definition is given. So the last concept over here is probabilistic programming. So this generally allows the developers to express complex probability distributions and models using code. So here we can see that the probability is expressed in the terms of codes. So here we make use of the model-based learning. So let us see a general schematic representation. So the model is being assumed. So from these assumptions we can make an inference strategy, and through the strategy it has an estimation algorithm which we can say that it is estimated in such a way that we can get the required output. Then it is implemented and executable. So these two forms, it definitely leads to the compiler where it checks for the errors, and the rest is for runtime. So this model-based learning will help us to create a model, and by using these three concepts we can make the complex problems into easier solutions and make use of it in the real world application. Thank you.